Releasing GenAI is not just deploying code. It means controlling how new behavior reaches users, watching for risk, and being ready to stop or roll back quickly. This module gives you a practical release playbook for production readiness. Up to this point, we've built the foundation: GenAI architecture, RAG flows, APIs, deployment choices, CI/CD, infrastructure as code, and versioning for models, prompts, data, and indexes. Now we shift from deployment to safe release. That means choosing rollout strategies, limiting user impact, detecting behavior changes early, and preparing fast response paths before we go deeper into observability and evaluation. GenAI releases need extra care because the user experience is shaped by more than application code. A small prompt edit, model upgrade, or tool change can affect tone, accuracy, safety, latency, and cost. In RAG systems, the release surface is even wider. Embeddings, chunking, indexes, document freshness, and ranking can all change the answer. Because LLM behavior is probabilistic, passing unit tests is not enough. We need validation across many examples, using quality trends and failure patterns, along with readiness checks for security, compliance, reliability, trust, and cost exposure. Before choosing a rollout strategy, define the release unit. In GenAI, that unit is rarely just application code. It may include prompts, model versions, retrieval indexes, guardrails, tools, data, and infrastructure. Each piece needs a fixed version ID, validation evidence, and a known rollback target. That metadata connects the release to CI/CD runs, evaluations, security checks, and approvals, making incidents much easier to diagnose. Blue-green deployment keeps two production-ready versions of an LLM application available at the same time. Blue is the stable version serving real users. Green is the new candidate, already deployed, warmed up, and tested with monitoring before users depend on it. When confidence is high, traffic shifts through a gateway, load balancer, service mesh, or feature flag. The main advantage is reversibility. If latency, quality, cost, or safety checks look wrong after cutover, teams can route traffic back to Blue while they investigate. Canary releases reduce risk by letting the new version prove itself with real users at very low exposure. You might start with 1 or 5% of traffic while the existing version handles the rest. This pattern works for prompts, models, tools, retrieval indexes, guardrails, and application code. Traffic can be routed by percentage, tenant, region, cohort, feature flag, or request type. Expansion should never happen just because time has passed. Move from stage to stage only when quality, latency, safety, and cost meet predefined gates, with automated checks or human approval where needed. For GenAI, Canary decisions need more than, is the service up? A model can be available and still produce unsafe, irrelevant, or expensive answers. Use a balanced scorecard. Reliability shows whether requests complete within acceptable latency and error limits. Quality shows whether answers are useful, grounded, and improving user outcomes. Safety checks for policy violations, prompt injection, data leakage, and tool misuse. User impact captures friction, complaints, and sentiment. Cost keeps token usage and provider spend from silently growing. The key is to define thresholds in advance. Green continues, yellow watches, and red stops or rolls back. Canary safety comes from setting the rules before anyone is under pressure. Start by defining what good means. Enough traffic to trust the sample, acceptable latency, error rates, safety outcomes, and cost. As the Canary expands, automated gates compare real behavior against those thresholds. If the signals stay healthy, the release can promote. If they degrade, the system pauses or rolls back quickly. For high-impact changes, add human approval and avoid vanity metrics. Promotion should depend on user-visible quality and business-critical risk, not superficial engagement. Shadow testing lets you evaluate a new version with real traffic without putting users at risk. The production system still handles the request and returns the only response the user sees. At the same time, a copy of that request goes to the candidate version. Its output is captured for comparison, but never sent back to the user. This gives you realistic evidence on accuracy, latency, safety, and cost before rollout. The main caution is data governance. Duplicated production requests may contain sensitive information, so masking, filtering, and access controls must be enforced. Offline replay is a dress rehearsal for release. Instead of sending real users to a new prompt, model, retrieval index, or app version, you run past or synthetic requests through it in a controlled environment. Then you compare the outputs with known baselines, golden examples, evaluator models, or human review. This helps catch regressions in relevance, factuality, safety policy compliance, latency, and cost before deployment. The key discipline is governance. Replay data should be anonymized, access controlled, and retained only as policy allows. If the candidate beats the threshold, it can move forward. Treat every release as a controlled comparison, not a vibes-based judgment. Start with production behavior as the baseline, then score the candidate on correctness, completeness, tone, grounding, safety, and format compliance. Automated evaluators can catch patterns. Deterministic checks can catch rules. Retrieval diagnostics can explain grounding failures, and human reviewers can handle nuance. The critical discipline is segmentation. Break results out by task, user group, language, domain, and difficulty. Average gains are not enough. A model can look better overall while regressing on high-risk edge cases, and those regressions should block release decisions. Rollback design is not just go back. It means naming the safe destinations before release, the prior application container, prompt version, model endpoint, vector index, and policy configuration. When an incident hits, feature flags and configuration-driven routing let you shift traffic quickly without waiting for a full redeploy. But rollback is only real if it has been tested. Practice the traffic switch, prompt rollback, and index recovery path during normal operations. Finally, keep the failed releases logs and traces. They are evidence for root cause analysis and better evaluations next time. Resilience is not only about stopping failures. It also means reducing capability quickly when risk increases. A kill switch should let you disable high-risk functions, such as tool execution, file upload, external browsing, or autonomous actions, without taking the whole product offline. Feature flags make that response targeted by tenant, user group, region, task type, or risk level. The system can then fall back to safer modes, such as retrieval-only answers, templates, or human handoff. Treat these controls like production safety equipment: fast, auditable, access-controlled, and visible to operators. Before a GenAI system goes live, run an operational readiness review as a forcing function. It asks one question: are we truly ready to operate this in production? Evidence should cover reliability targets, dashboards, alerts, evaluation baselines, security controls, privacy, cost limits, and provider dependencies. It should also cover the human side: runbooks, escalation paths, incident owners, on-call coverage, support handoffs, and rollback plans. The result is not a vague confidence level. It is a clear go or no-go decision based on documented readiness, not optimism. The core lesson is that GenAI release should be controlled, measurable, and reversible. Use staged release patterns to limit exposure, monitor behavior against baselines, and prepare fast recovery through rollback, kill switches, failover, and degraded modes. Readiness also means clear SLOs, security controls, runbooks, cost limits, and ownership. Next, we'll deepen this with LLMOps observability, evaluation, and reliability.